All right, scholars, good morning. Welcome. So this is going to be your activity for processing for Unit 1, Lesson 2, activity for processing 1.2. Before we begin, we're going to do a very quick refresher on simplifying fractions. If you wish, after I do this really quick review, you can always type this into YouTube and invite yourself to look at other work from other content creators, lots of fabulous mathematicians out there. My only advice is if you do go on YouTube for other lessons from other people, is I would advise you to go with the lessons that have the most views. So if you have something that has only 12 views versus something that has like 5.7 million, there's probably a good reason why that one has 5.7 million and that one only has 12, right? Not to say that this one couldn't grow into a bigger one, but I would go with what has been viewed the most, right? That's my recommendation. All right, so here's my take on it. Simplifying fractions. Let's suppose we have the fraction 16 over 64. I want to reduce this fraction as much as possible. So I like to think of the multiple that 16 and 64 share. There are many multiples they share, but let's say I choose the simplest one. And notice they're both even numbers. So I can divide both the numerator and the denominator by 2. I then notice that 8 and 32 are also even numbers and can be reduced further. This time I recognize that I can divide by 2 again, but I can actually aim for a larger number. I can just divide by 8. So you might have even in your head when I said, oh, I could divide by 2, but I can choose a bigger number, you probably thought 4. That's fine too. So if you can think of the largest common multiple that they both share, and you can do that immediately, I would advise you to do so. It speeds up the simplification process. So after some reduction, we see that we reduced the fraction 16 over 64 all the way down to 1/4. Now here's a little cool trick. We divided by 2 and 8. So that means we could have divided by the product of 2 and 8. So if I do this again, I could have divided both of them by 16. 2 times 8 is 16. But I didn't know that the highest multiple that 16 and 64 shared was 16. So I chose 2, which is a little slower, required 2 steps, but either way, that should do it. As long as you get to the lowest possible fraction, as far as it being simplified, you're totally okay. It could take 5 steps if you want, doesn't matter. But whenever you recognize higher values, go for those. Okay. Allow me to erase this. I could do more examples on simplifying fractions, but once again, I'm going to just invite you to kind of do that there at your leisure as you wish. Okay, now geometric sequence is, now we're going into different types of sequences. So last thing we looked at the idea of sequences that can grow either by one of the two operations of multiplication or addition. Geometric sequence is a specific type of sequence that actually uses multiplication. Once again, that's my multiplication symbol, the little star. So an example would be, let's say I had the number 4, and I multiplied it by 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So on and so forth. So a geometric sequence is one where you multiply. Now, in that last video, I did talk about a special situation where you can multiply by fractions and something interesting happens, and we're going to take a look at that in today's video. So, what if we actually have something like this? Let me begin example 1. What if we had a geometric sequence like this? That's kind of strange because I'm telling you it's a geometric sequence, but we're actually seeing it decay. The values are getting smaller and smaller. So the second term is smaller than the first term, and the third term is smaller than the second term. So how is it possible that this is a geometric sequence if we establish that it needs to be multiplication? And when we think of multiplication, we commonly think of growth. Well, towards the end of the video, I kind of dropped a hint there. The answer is going to be fractions. Fractions is how this geometric sequence is made possible. So you could say I'm dividing. That's fine. But now we're in algebra 2, so we're going to think of division as a different way of saying multiplication. Allow me to explain. So you could say divided by 2. That's fine. Or what you can do is you can say I'm multiplying by the reciprocal of 2. The reciprocal of 2 is 1 over 2. Okay. Just a quick note on reciprocals. Okay, so let's say you're dividing by 5. And that's the same thing as multiplying by 1 over 5. Right? Let's say you're dividing by 1 over 5. And that means you're multiplying by 5. So a geometric sequence is always multiplication, but if your brain likes to think of division, just use this little trick and it will assist you. Now, here's another one, another way of thinking about it using decimals, which are totally okay, not my preferred route. And I'll talk about that when we get into certain fractions that do not play nice when converted into decimals. But let's say we instead said we're multiplying. Actually, I'll get into that in a moment. I'm jumping ahead of myself. So let me go ahead and do this. So one thing that we can do to find the growth factor is the number that you're multiplying by. That's your growth factor. Which we just saw a moment ago, the growth factor was going to be 1 over 2, which is the reciprocal of 2, right? One way we can find that is by taking the second term of our sequence, which is 200, and placing that over 400. And the reason I went over simplifying fractions is because that will play a critical role in you finding the growth factor using this method. So you could do it mentally for today's exercises, but when you get into more intricate and complicated situations, having procedures and techniques available are going to assist you when you get into more complicated scenarios. So using this, one shortcut I know is I can divide the top and the bottom by 100. And I can simplify once again. Okay. Now, how you get from 200 over 400 to 1/2, that's up to you. However you wish to do it. But now I can call this my growth factor. So this is no longer a question mark. I now know using the method where I divide the second by the first term, I can find the growth factor. Now, I can also verify that that growth factor works. So what I'm going to do is I'm going to get 200, which is the second term. Actually, allow me to switch colors here. And multiply it times the growth factor. Right now I'm buffering because I'm like, should I show you how to do it? And the answer is yes, I should. I'm going to put a little invisible one there. I'm going to put a little check mark here to say, oh, the growth factor seems to hold up. So if the growth factor that you get from the first step works to also give you the movement from the second term to the third term, then you can feel confident that you can now provide the next following terms for this sequence. So what I'm going to do is I'm going to grab the 100, multiply that times our growth factor 1/2. 1/2 of 100 is 50. Now I'm going to grab the 50 by 1/2, it gives me 25. And then the last one, which is 25, will it fit? Yeah, we are good. It'll give me 25/2. You could write this as a decimal, totally okay, but in my class, I'm a huge fan of fractions. Improper fraction that might be bothering you, so if you wanted to turn it into a mixed fraction, that's totally fine, but not necessary. Those exist in real life, and I'm going to accept them as they are. So that is a process by which you take the known values of a sequence, use the first two terms to find the growth factor, and then use the growth factor to find the remaining mystery terms of the sequence. Now comes the tricky part. This next part that I'm going to say, you can either fast forward the video because it's totally not necessary, but I do want to talk about decimals real quick and how to use those. So I'm not saying don't use decimals, but I tend to shy away from them when doing this for my own reasons. And let me show you how to use a decimal. And on the next example, I hope I can, I'm not trying to convince you, but at least show you how decimals can get a little tricky. Let's hop into this though. So 1/2 as a decimal, if you divide 1 by 2 on your calculator, it'll give you 0.50. You can also use 0.50 as your optional growth factor if you're asked to present your growth factor in decimal form by dividing the numerator and the denominator to get that decimal. So then I would multiply 100 times 0.50, and I promise you it will give you the 50 there. Multiply 50 times 0.50, and it will give you 25. So on and so forth. So that's how you would use a decimal growth factor if you're one of those people, and that's perfectly fine. Now, here's why I shy away from them. Let me hop into example 2 now. Checking it comes out. Sometimes I write and it comes off the frame. So I want to make sure that I am in my notes. Okay, so here are the terms. I wasn't supposed to give you these. I mean, it doesn't matter. It really doesn't matter. So here we're told that this is a geometric sequence, and we have to remind ourselves that a geometric sequence is one in which the terms are multiplied by a growth factor to get the next one in the list. So right now what I'm actually going to ask you to do is pause the video and try this for yourself. See if you can find the growth sequence and the next terms, the growth factor, sorry. See if you can find the growth factor and the next terms of the sequence on your own. Then hit play, come back, and let's run through it together. So I'm gonna keep going through it because I'm in lifetime and you're not, so you can pause, and then when you hit unpause, it's like I just kept going or whatever. All right, so let me use that method where I have 81/243. And I get 1/3 after some simplification. Now, those of you who use the decimal situation, you should have wound up with like 0.33, something like that. You're going to notice your calculator gives you a bunch of values sometimes. And what happens is if you get a long list, let's say it was like 0.33333333, then you're going to have to type those in every time when you multiply that growth factor into the terms. The reason I suggest this is because it's easier to manage. Now, if you know how to multiply by this kind of a number here, where it goes on for a long time, go for it. Or if you have another method, share it with us. We'd be more than happy to share that. So you could use this, totally okay. I am not going to, but I thought I'd just throw it out there for you to see it and if you want to play around with it, to experiment with it. So I need to check, first of all, that this growth factor is correct. So what I'm going to do is I'm going to grab the second term, 81, multiply it by my growth factor, and it should give me 27, right? So 81 divided by 3, is that 27? Well, let's see. It works. I could have used a calculator, but whatever, I did some long division. Okay, so it gave me 27. So now I'm going to multiply 27 by 1/3, which is our growth factor. Which gives us 9. And if I repeat this process, I hope you can trust me. But if not, you can do it for yourself, which I hope you already did. The next terms should be 9, 3, and 1. Okay. Now, if you multiplied by 0.33 each time, and it was like a bunch of 0.33333, experiment with that, and then hopefully you see why I tend to shy away from the decimals. Not that I'm afraid of them or anything like that, but I just find this to be the easier route using the fraction in this exercise. Now, let me show you the alternative method that I mentioned in the last problem there. Using division. So we divide by 3, which is the same as multiplying by that reciprocal. Okay. So you could have done that here too. 81 divided by 3 is 27. Or we could say we're multiplying by 1/3. Okay. This is going to be the preferred format for geometric sequences. When you're asking for the growth factor of multiplication, if you notice it's declining, the odds are that it needs to be a fraction. And if you can't visualize the fraction, you can use the method where you divide, or you can actually just divide and then reciprocal it and get your growth factor that way. Many ways to go about it. All right, let's hop into our last problem here, and we'll call it a day. Example 3 is also a geometric sequence. And you're going to be asked to find the growth factor and determine the next few terms of the sequence. So let's try this out. Okay, so here, pause the video, try to find the growth factor and the next terms of the sequence. Using any of the methods where you use a decimal, you can use a fraction, or you can divide, reciprocal it, and find the growth factor. Those are 3 different strategies you can use there. Choose whichever one works for you and then fill out these things and provide the growth factor. All right, I'm going to continue though here. So I'm actually going to do a little cheat here. I know that 64 divided by 4 is 16. I don't know why I know that from my memory, but I do. So that means I'm actually multiplying by a growth factor of 1/4. So this time I'm actually going to try it over here. Does this work if I multiply by 1/4? So 256 multiplied by a growth factor of 1/4. Does that give me 64? And it does. Okay, so I can continue this process of multiplying by a growth factor of 1/4 here. So 16 times 1/4 is 4. 4 times 1/4 is 1. And 1 times 1/4 is 1/4. Or if you were using the decimal of 0.25, that last answer would be 0.25 right there. Okay, so your growth factor could have been 1/4. I prefer that. Or 0.25, which is also okay. All right, with that said and done, thank you folks for going through this lesson, and good luck to you.